All right, section 8.7 is about a thing called vectors. I don't know if you've ever talked about these before or not. If you guys eventually take physics, you might have talked about this in ninth grade physical science. Does anybody remember that? Talking about vectors. Did you guys do that? Anyway, are you still taking it now? Okay, we got ninth graders in here. Yeah, I always forget what grade you guys are in. Anyway, so you might have already talked about it. You may not. Have you done a section on physics yet? That's probably
on that now.
You're doing it right now. Okay, so ask your teacher about vectors and they'll tell you too. All right, but that's what we're going to study a little bit about it now. When you take physics, when you're a senior, probably most of you would take it when you're a senior. You're going to be dealing with a lot of vectors. Almost all of physics deals with vectors and how to add vectors, subtract them, and all that kind of stuff. So let's just basically talk about what a vector is. Okay, a vector, very simply, it's something that has two things. Let's say it has a starting point right here. Okay, it's got two things. It's got magnitude, okay, and it has direction. For instance, let's write this down first. Let's listen now. Magnitude and direction. Magnitude means how much of something, or like one of the basic things you do in physics is talk about distance, velocity, time, and that kind of thing. Okay, that's one of your basic formulas that you do in physics. When we talk about a velocity vector, or let's say a velocity vector, we talk about like how fast. So if you're in a car and you look at your speedometer, it tells you how fast you're going. That's the magnitude, okay? How much of something. There's also another thing in physics we call displacement. It means how far you go. Okay, the how far you go is the magnitude. There's other things. There's acceleration, there's forces, there's all kinds of stuff like that that are vectors. Okay, one of the simplest ones is velocity. We'll just talk about that. Velocity is how fast you go. Okay, so I'm just using velocity as just one example out of many that I could use, okay? So how fast are you going? That's the magnitude. So if you're going down the road and you look at your speedometer, and of course you're not going above 55, right? Unless you're in 65-mile-an-hour lane. So anyway, how fast are you going? That's the magnitude. But that's not a vector. Just having one of those is only half of the vector. In order to have the complete velocity information, you want to know how fast you're going, and you also want to know in what direction that you're going. Okay, so we'll say this. A lot of times, especially in here in math, we're going to say what angle. Okay, so magnitude, how fast or how much of something. It's not always how fast. Okay, in velocity, it would be how fast. In displacement, it would be how far. In the forces, it would be how much force or how much, I don't know, pressure, I guess, or whatever you want to say. But magnitude is just how much. So how do we measure the magnitude of this? Well, we measure the length of the line. So from here to here, okay, the length of that line would be the magnitude of this. All right? Well, what's the direction? The direction is what angle we're talking about. Now, I haven't put any numbers in here for us to find it or anything, so don't get too worried about that. But let's find the angle. And most of the time, not all the time, but most of the time, we try to figure out our angle from the positive x direction. So watch. That angle right there, we'll call it theta. That angle right there would be my direction. Now, again, it doesn't always have to be taken from the positive x direction. A lot of times it is. That's why I just wrote it right here. So a vector is two things. It's magnitude. How long the line is basically what it is. Okay, the length of the line indicates how fast you're going or how far you went or what force is being applied or something like that. Okay, the length of the line is the magnitude. The angle that the line is going is your direction. All right, so that's two important things you need to know about vectors. All right, let's see. They asked you to do a couple things. Again, we're not going to finish this whole thing today just because it took a little too much time answering questions today. So we'll finish it up tomorrow. Let's see where I want to go. Let's do this. Kind of alluded to this before, but let's just do it again. So a lot of times you think of this as being the x-axis and this is the y-axis, and what I said before was like if I had an angle coming out like this, that would be considered my vector. A lot of times we put an arrow on there because it could keep on going, all right? Or it could stop too if you wanted it to, but a lot of times we show vectors with an arrow. So let's just do it with an x and y axis. We call this thing, it's a vector that's in standard form. So where is the beginning of this vector? Where is it? It's at the what? Give me one word. It's at the origin, right? So in standard form for a vector, the beginning of this vector is at the origin. Okay, and then it goes which direction? A lot of people say it goes up. But think of a clock. Which direction are we going? It's counterclockwise, right? This is the opposite direction the clock would go, right? So this would be actually counterclockwise. So that's what we normally do. That's why it's standard. It doesn't always have to be like that. Sometimes they'll have word problems where, like if this is east, what would this be if that was east? That would be north, right? This would be west, and this would be what? South. So a lot of times in word problems, they'll talk about a vector in terms of east, west, north, and south, right? So in this direction, this would be east if I went to the right, but if we went this way, we would say this would be north of east. Does that make any sense? So this is east. This right here is going what? It's in the northerly direction, but from where? From east. So this would be in the north of east direction. You may see a few of those. You'll see a lot of that when you get into physics, but in here we're dealing with basically just the math part. Okay, let's do one quick example here. Probably won't even get done what I thought I would at the beginning of class, but that's okay. It says write the component form of CD. So let's scooch down here a little bit, and let's write a little XY axis. And let's put a point, let's see, at -1, 3. 1, 2, 3. Actually, let's put this in a different color. So there's one point right there at -1, 3, and then there's another one at -3, -1. 1, 2, 3, -1. Okay? And what we want to do, say it starts here, goes through there, and we'll put a little arrow. So this is where it starts, this is where it ends. By the way, I think they do give a couple words for this. They call this the initial point. Initial. That usually, when they say initial, that means where you usually start from. Okay, and then they call this, I think, the terminal. Yep, they call this right, that point right there, the terminal, because that's where you end. Right. So initial point and terminal point. This is where you start. This is where you end. Here's the question they ask you to do. It says write the component form of this point. That's CD. I'll write that word out so you know what they're asking for. Write the component form. Now we have to talk about this because I haven't even mentioned what the word component form means, but this is what they're talking about. What they want to do is there's another way to write this. Instead of saying this is the point, what did we say this was? -1, 3, right? And what was this point? -3, -1. Instead of saying, okay, well, it starts at -3 and it goes, I'm sorry, it starts at -1, 3 and it goes down to -3, -1. Instead of saying that, that's a little wordy. Here's another way they do this to describe this line right here. And basically all you're doing is just, it's kind of like finding the slope, to tell you the truth. When you find the component form, what you're going to do is you're going to write it in these little arrow things. They're kind of like brackets, kind of like parentheses. They just kind of surround the two numbers that you want. So the way that you write this is you just subtract the x's from each other, and we are going to subtract it in a certain order. Let's move this over a little bit. Okay, we're going to go x2 minus x1, and then we're going to put a comma, and then we're going to go y2 minus y1. Now when I say 2 minus 1, that means the terminal minus the initial, the second one minus the first one. The arrow is in this direction, so this is the terminal. So this would be the x2 and the y2. This one right here would be the x1 and the y1. Those points right there. So to write it in component form is very, very simple. It's just knowing how they want you to write it. So you just subtract the x's from each other. But you got to do it in this right order. You got to make sure you go the second one minus the first one. Okay? It does absolutely make a difference which one you do. So if I go x2 minus x1, what is it? It's negative 3 minus what? Negative 1, right? Okay, and then let's do the same thing with the y's. What's that? It's negative 1 minus just positive 3. And then just finish it up and we're done. That's what? Negative 2, and that's negative 4, and there it is. Okay, that's writing it in component form. That in and of itself doesn't really do much for you. What they're trying to do is they're trying to lead you up to something that's going to happen a little bit later. Okay, so this in and of itself is not really that super important, but it is going to help with stuff that we're going to do just a little bit later. All right, so let's just make sure that we know how to do that. And there will be a couple questions where it says, write the component form of this vector. By the way, let me show you what the symbol for vector. Write the component form of vector CD. We don't just write it like a line. We don't even write it just like array. This is array because it has a starting point and it keeps on going. So we don't really write it like that. This is how they write it. Watch, and we'll be done. You write a little line and then just kind of like a half an arrow. That's kind of weird. Instead of a whole arrow, for vectors we write like a little half of an arrow. So CD, vector CD is written like that. Okay, so let me write it a little bit bigger. Boom. That's how you would write a vector, just like that. We'll finish this tomorrow. I'll give you some work on this tomorrow. Okay?